Imagine two writers working on the same novel. One of them keeps a journal that honestly records everything. The day they split off to write a side chapter, the day they came back, and the exact moment the two storylines were stitched together. The other quietly rewrites her own pages, so it looks like she wrote them in one smooth sitting right after the main story. No detour, no mess. A perfectly clean timeline that never actually happened that way. Both novels end up at the same place, with the new chapter sitting neatly on top. But one preserves the true, tangled history, while the other invents a tidier story. In code, those two writers are called merge and rebase. Teams burn hours arguing merge versus rebase without knowing what each command physically does to the commit graph. That leads to tangled history, lost commits, and the dreaded force push that overwrites a teammate's work. A commit graph is a chain where each commit points back to its parent. Merge and rebase are two different ways to bring the commits of one branch onto another. Merge joins the two tips with a single new commit that has two parents, recording the real divergence. Rebase abandons your original commits and creates brand new copies replayed on top of the target, producing a straight line. Both operations start by finding the merge base, the most recent commit that both branches share as an ancestor. For a merge, Git performs a three-way comparison between your branch tip, the other branch tip, and that merge base, combining non-overlapping changes automatically. Git then writes one merge commit whose first parent is your branch and whose second parent is the branch you merged in, so the history graph forks and rejoins. If your branch had no new commits since the base, Git skips the merge commit entirely and just slides your branch pointer forward, which is called a fast forward. For a rebase, Git first saves the list of your commits that are not on the target branch. It resets your branch to the target tip, then replays each saved commit one at a time, reapplying its changes and creating a new commit with a new hash and a new parent. If a replayed commit conflicts, the rebase pauses on that single commit so you resolve it, then Git rebase. Continue resumes with the next one. When finished, your branch is a straight line on top of the target, and the original commits, now unreferenced, linger in the ref log until garbage collection removes them. You branch off main at commit C, make commits D and E, and meanwhile a teammate adds commit F to main. A merge produces a new commit G with parents E and F, and the graph clearly shows two lines that split and joined. A rebase instead replays D and E onto F as new commits D' and E'. So the history looks as if you started your work after F, perfectly linear, with the original D and E discarded. The dangerous misconception is that rebase moves your commits. It does not move them, it copies them into new commits with different hashes. Because the hashes change, anyone who already pulled the originals now has commits that no longer match yours. That is why the golden rule is to never rebase commits that have been pushed and shared. Merge is always safe for shared history because it adds new commits without altering existing ones. Like the honest journaler versus the writer who rewrote her pages, merge records history honestly with a two-parent commit and is safe for shared branches, while rebase rewrites your commits into a clean straight line with new hashes and must stay on private, unpushed work. I settle the real engineering debates with how the machinery actually works every day. So subscribe to Tech with Joel. Does your team merge or rebase its pull requests? And has it ever gone wrong? Tell me the story below. Subscribe to Tech with Joel.